And let me know if this has happened in your house too. You want to go for a party, you have fixed a nice maybe a restaurant or a park or something or somebody's house, and you decide that we are all going to meet, all your friends are going to gather, and you're all going to have fun. And you have told your parents in advance, and then your mom is like, no, this Saturday at that same time we are going to visit Aunt Champa and you cannot go to the party. And then you are like, no, but mom, I just told you just some days back that I have to go to that party. All our friends are coming. We have decided it much before. And then your mom is like, no, 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 nothing doing. We are going to visit Aunt Champa. And then your dad, who is silently probably reading the newspaper, he's like, but wait a minute, I have to watch the match. The IPL is going on at the same time. So I don't think I can come. And then your mom gives a very nice angry stare, and then your dad is like, okay, fine, no issues. I'm going to miss the match. I'm just going to head along and we will visit Aunt Champa. And then all of them make sad faces and you visit your relative. Yeah, has it happened? Yeah, has it not? And you know, exactly the same thing is happening with you too right now. Just look at this. It's like a nice family who could not make up their mind to have these exams on different dates. Look at this. NEET 17th July, JEE Mains 21st July, and you have your bits at 22nd July. It's going to be fun. And who is going to budge? I don't know. Is somebody going to be like, okay, fine, we can't be together, we have to split apart? I don't know who is that one going to be. I don't know. It's going to be one crazy mess out here. And if you guys agree with this, let me know in the comments as well as in the chat box. So let's begin with the class. And something should change. Obviously, the exam dates are close, guys, because a lot of you are asking about it. So I'm pretty sure things are going to work out in your favor too. So my name is Shreyas. I'm the physics master teacher, training kids for a long time. You want to know more about me? Go ahead, go to Instagram, check out this handle. You'll get to know a lot about me. And in today's class, we are going to see all about nuclear physics, what's there in the nucleus, the nuclear forces, the binding energy, and also we're going to talk about the radioactivity, the decay particles, and also the law of radioactivity and some problems on it. Okay, so let's begin with the class, and I hope you have smashed the like button. Hello Vandana, hi Daljan, hi Parai, I'm very good. How to learn theory easily? Teach somebody or teach yourself, that's it. Hi Nancy, hi Harishma, hello Parai, hello Siswa, welcome, good evening. Yes, I know Shinchan from the Cartoon Network. So during my time, it was not Shinchan, it used to be Popeye, Scooby-Doo, and Tom and Jerry and all of that. These days, then it came to Pokemon, Doraemon, and all of that, and now it's Shinchan. Cool. Mansa, good evening. Hi Pooja, welcome. So let's begin with the class. I hope you have hit the like and the subscribe button. So let's revise the theory concepts, and let's also then solve the problems, concept problems. That's what the lecture is going to be. Roughly, the lecture will be around 1.5 hours. So keep that in mind. Okay. So semiconductors, Parry, obviously it will be conducted. Hold on, no, I can't do semiconductors right now. Right now we are doing nucleus. So let's do nucleus. You will see the schedule. Everything will be put up, okay, on the Telegram, as well as it will be coming up in your upcoming streams. Everything will be taught. Hold your horses. Nucleus. So remember, the nucleus is a dense part of the atom where, you know, protons and neutrons reside. Around the nucleus, you have the electrons revolving around them. Protons and neutrons roughly have the same mass. Protons have charge, neutrons don't have charge. Roughly the masses are same, like I told you. And they are held together by very strong forces called as nuclear forces. Like you can see, the mass of neutron 1.67 into 10 to the power minus 27. Mass of proton 1.672, slightly less than the mass of neutron, 10 to the power minus 27 kg. So together, protons and neutrons, they are called as nucleons. Like you are the residents of, let's say I stay in Bangalore, so I am called a Bangalorean. right? So same way, or somebody is saying in Delhi, he's called as Delhiite. So all the particles who stay in the nucleus, what are they called? They are called as nucleons. I hope that is fine. Now, if you look at these masses, if you convert it into AMU, okay, atomic mass unit, it's almost very close to 1 atomic mass unit, very close to 1 AMU, but there is a small difference in the small difference in the decimal places somewhere, after 3-4 decimals. Don't worry about it. Hello Kumar, hi Bharat, hi Sibi. Nice to know, Paray, you're from Kashmir and you're a Kashmiri. Yes, exactly. Nitish, welcome bacha log. Now, you should know how things are denoted, how atoms are denoted with their atomic mass number and atomic number. So whatever comes on the top is the total number of nucleons, meaning protons and neutrons together. Whatever comes below is the chemical property. It decides the chemical characteristics of that element. Hence, that is atomic number. That's Z always. And we know that where is it? Yes, that A is nothing but Z plus N, right? It is Z plus N. Z is the atomic number, N is the number of neutrons. Z decides your chemical characteristics. Chemical characteristics is the atomic mass number, the total number of protons, and the neutrons present inside of it. Everybody knows this. Great. Now, I have also told you about AMU. What is AMU? AMU is the special unit at a very minute scale. Like you can see in the previous data sheet, the masses of neutron, electrons, protons are very small. Writing it like this becomes very difficult and also difficult to understand it. Instead, we defined a new unit so that it is understandable for us. You can visualize it clearly, and that is AMU, which is 1/12 the weight of a C12 carbon atom. So you should take C12. There are many isotopes of carbon. Do not take any random isotope. The C12 isotope, divide it into 12 equal parts. One part of it is 1 AMU, which is 1.66 into 10 to the power minus 27 kg. Like I have told you before, the mass of proton and neutron is roughly 1 AMU. Yes. So Rupa, I will be doing it from the point of view of the competitive exams like KVPY, NEET and JEE, but from board's point of view, okay, because it has more of theory and all of that, this session will be helpful from the theory and the basic problems, but writing those answers and other things, we will have special sessions for that as well. But this will help you there, definitely. Yes, it will be helpful, Sundareshwar. Okay, so moving on to the next part, you should know the different kinds of nomenclature, especially isotopes, isobar and isotones. Isotope means chemically they are same, but mass number wise they are different. Like hydrogen can have 1 proton or 1 proton, 1 neutron, or even higher number of neutrons. Neutrons don't add any change to the chemical properties. It just makes it bulkier. The nucleus becomes bulkier. Electrically, it does not change the characteristics. So these are the isotopes. Even the isotopes of oxygen are mentioned over here. Same thing you can have for isotopes for nitrogen, carbon and all of that. Isobars means they have the same atomic mass number. Chemically, they will not be the same because the total number of protons and neutrons will be constant, but each element will have different protons and different neutrons. Their sum is constant. Like over here, there is 1 proton and 2 neutrons. Here, there are 2 protons and 1 neutron. Their sum is constant. Like you can see, they are called as isobars. I hope this is clear. Yes, numerical bhi karvaunga Rupa. Don't worry. Chill, Madi. It will be done. Okay. Isotones. Isotones are those elements which have the same number of neutrons. Neutrons particles should be same. Like lithium, 7, 3. So 7 minus 3 is 4. There are 4 neutrons. And here you can see 8 minus 4 is also 4. So both these elements have the same neutrons, hence they are isotone. tone, N, that N comes, so same neutron. That listen to that spelling or listen to that voice, isotone, neutrons. Isotopes, everybody knows. Same element, different mass number. The only thing left is bars, isobars. The bars have different, chemical properties, but they have the total number of nucleons. Protons plus neutrons are the same. Or you can also remember it this way. What happens in a bar, guys? What happens in a bar? In a bar, people gather, right? Friends gather in a restaurant and a bar. Okay, sorry, I shouldn't be saying this, but whatever. Same way in isobar, this is a special bar. In this special bar, who came? Protons and neutrons came. They are coming together in that special bar. Everybody understanding this? Clear? Hello Sharmila, hello Hari, hello everyone, welcome, welcome. Champa has come just some time back. You missed the starting part. Street boy, you missed the starting part. Champa came and went. You can rewind back the session later on. Okay, now the nucleus size depends on how many particles are there. If there are more particles, there will be bigger radius. The size will also be more. Everybody with me on this? And how does the radius of the nucleus depend on? The radius depends on the total number of protons and neutrons. What is the total number called? Protons and neutrons together? They are called, that is called as atomic mass number. So radius is proportional to a raised to 1 by 3. Very important law. Remember this. Radius is some constant into a raised to 1 by 3. Keep this in mind. Okay. So cube root of the atomic number into some constant. That constant is 1.2 femtometer. And this is very small. This F stands for, how many of you know this? This F is which power of 10? What should I put? Let me see how many of you are attentive and know this. Hi Jayashree, hello Ganuklatan, welcome. Kanmani, Neelarjan, welcome. Hello, hello, hello everyone. Hi Roshni, hi Sharmila, welcome. Join in Bachalo. Yeah, what's this value? 10 to the power minus 12? Na, wrong. It is minus 15. Minus 12 is pico. Minus 9 is nano. Minus 6 is micro. Minus 3 is milli. Milli, micro, nano, pico. And then comes your F. Very good. Looks like all my warriors know this. And the density, when you divide mass by volume, this has been asked in NEET and JEE and many other competitive CETs as well. The mass by volume, when you divide it, it comes out to be a constant. Because the mass, when you calculate it, when you calculate the mass, which is density into volume, you will see the term A gets cancelled out no matter which nucleus you take. The nucleus of hydrogen, nucleus of iron, nucleus of beryllium, doesn't matter, it turns out to be a constant. Keep this in mind. Okay? A lot of people think, oh, if I take a big nucleus, the density will be more. No. The volume also increases, mass also increases, density remains the same. Okay. Okay. Now, I'm coming to that, Rupa. Now, the next important point is, obviously, what is Pandu thinking? Exactly what Rupa is thinking. Rupa is thinking the same thing what Pandu is thinking. Why should two protons stay together? Do you not like somebody in your school? Is there some person you don't like at all? And imagine you have to be project partners with them. Yeah? Has it ever happened, guys? You have to work on the same project or you have to do the same kind of assignment with somebody whom you do not really like in school. And they're like, okay, I don't want to stick to you. I don't want to stay with you. Okay, you stay far away. I'm not going to stay close by. So all these kind of thoughts and all these kind of fights happen around in your school as well. Now, the same kind of fight happens within the nucleus. Between whom and whom? Proton and proton. Obviously, positive repels electrostatic charges. Now, who will be the mediator? Mediator is some person who will be like, hey, come on, listen. You guys don't fight. Come here. Okay, what's your problem? What's your problem? Okay, you don't like him. Okay, you don't like him. All right, listen. I will tell you something. I will give you this. You do that, then he will do this. So, somebody who's trying to console them, are like, okay, stick together. I know they hate each other. And they are just staying there because of that third person. That some person is there to hold them together. If that person is like, okay, wait, let me just have some sandwich, or let me just play and come, or let me just check on something, or let me just answer the call. If he goes away, Then these two people are like, okay, get lost, okay, I don't care about you. They will start fighting. So the third person is very important. The third person is very important, who is going to hold them together and who is going to work against their hatred. Is that clear, my warriors? And who is that person? That is neutron. So neutrons help protons stay together. As there was no job of neutron, because neutron is a neutral particle. So what will a neutral particle do? It can't do anything. But there is a special kind of force, and that force is called as your nuclear force. That nuclear force helps in, binding those protons and also making those particles inside the nucleus stick together. If the R0 changes, yes, the density will change, like you can see in the previous one. Over here, our density is dependent on R0, of course. Okay. Now, having said that, these nuclear forces are very strong. They are very, very, very strong than electrostatic, because think about it, two protons hate each other. To make these two protons which hate each other stick together and love each other takes a lot of effort. So nuclear forces are very strong, but they are very short range forces. Meaning the moment the third person who is holding them together just looks away and like, okay, what are you saying? These two people start fighting. Hasn't it happened with you as well? Maybe your mom is like staying in front of you and your brother and sisters are, on the dining table or in the room, and you guys are fighting with each other. The moment mom looks like, okay, we are all cool. Okay, we are together. And the moment the mom looks away, like with your pillow fights. Same thing happens over here. Yeah. So that's what is a nuclear force, my warriors. These are extremely strong forces, but for very short range. They do not depend on the charge. They depend on the spins. Okay, of the nuclear particles. Okay, and it's a saturated force, means it's very, very concentrated, very, very strong in the close vicinity, and suddenly dies out, suddenly goes away when you go far away. That's what happens. Shruti saying it happens daily. Dr. Zen also agrees. Nilarjan also agrees. Is nuclear force strong? Yes, it is a strong force. Yes, and it is mainly attractive in nature, and it is not dependent on the charge. It's also one of the fundamental forces in nature. Gravitation is a fundamental force. Electromagnetic is also fundamental force. Nuclear is also one of the fundamental force. It is not a derived force. For example, weight. Weight is not a new force. It is actually gravitational force. Tension is not a new force. It's also electromagnetic force. So nuclear is not a derived force. It does not depend on other things. It's a new type of force altogether. Okay. Having said that, let's move to something called as mass defect. Let's talk about mass defect. Now, I asked this question to many students, and every time students fail to answer this. Let's see if you guys can answer it. Let's see. Yeah, what does it mean? It depends on the spin. So these particles, like electron spins or revolves, these particles also have spin. So the spin decides the forces between them. That's what I mean by the spin of the particles. They rotate. Okay, their rotation, they are rotating like this. So it decides their, force of attraction. All right. Now we don't have to deal in so much of detail. That is not their nuclear physics in so much detail, sir. What is the force? No, nobody will ask you unless you do MSc chemistry or engineering physics and you become an atomic scientist and stuff like that. Okay. Now coming back to mass defect, let's see whether you can answer this question. If I tell you there are two protons and there are two neutrons. They are all independent, and I put them on a weighing machine or a weighing pan and I see what's their weight, just hypothetical, and I bring them together. And right now they are all a part of helium nucleus. Proton, proton, neutron, neutron. And this also I weigh. Okay, this also I put it on a weighing machine. Which one will be heavier? Independent or together? This is independent, and this is inside the nucleus of your helium or any other atom. Which one is more? Which one is less? Come on, let's see. Independent will be heavier, or nucleus will be heavier, or both will be same? Hello Nishi, good evening. Many of you are saying independent. All right, Harishma saying For a moment, Harishma, I read your name as Hiroshima, and I got scared because we are talking about nuclear physics, and then I read Hiroshima. I'm like, oh my god, what is happening? Okay, so now I read it correctly. So guys, the answer is okay. In an extremely small space within, how is this possible when proton? Rupa, I think you missed my discussion. I just told you there is a third entity, nuclear force. That force is attractive. I just told you, right? I think you were there right now. Yeah, that nuclear force is the one who makes those protons, those two people who hate each other, stay together. Hi Naz, hi Srinivasa. Guys, now my point is, this independent, you will be like, sir, they should be same. No, the independent is actually heavier. Yeah, it weighs more. Like, what nonsense? Four things, whether it is separate or whether they are together, they should weigh the same thing. How does it matter? The answer is, the mass is less here because some amount of energy is liberated. Like, okay, so what? I did not get it exactly. See, what happens is when they are independent, their mass is more. The mass before is more. The mass afterwards is less. So there is some difference in that mass. The difference in that mass is destroyed and created into energy. Einstein said mass can be converted into energy by destroying it, and if you destroy energy, you get mass. So, actually speaking, the law of conservation of energy has to be extended, and it should be something like the total amount of mass and energy equivalent is constant in this universe. Because even energy can be created and destroyed only if you convert it into mass. That's what it is all about. And that difference in the mass is released in the form of energy. When you release energy, you become very happy. I don't want to give examples, but a lot of people release gases and they become very happy. Isn't it? Same thing is with nucleus. So people become happy when they release gases. Nucleus becomes happy when it releases. Particles become happy when they release energy. Understood? Understood, my warriors? More the energy, happier they are. Very happy they become. So satisfied, like, oh, thank God, that was awesome. I love that. Okay, great. Sorry guys, had to give that example so that you remember it. Okay, great guys. So the mass defect is number of protons into the mass of the proton into, this is actually number of neutrons, guys. You can think about it. This is the number of neutrons. Okay, this is the number of neutrons into the mass of neutron. So what is this? Protons weight plus neutrons weight minus the mass of the nucleus. That is your mass defect. Obviously, the total weight of the protons plus the total weight of the neutrons minus the mass of the nucleus, that gives you the difference. That is your mass defect. Are you going to sit and by heart this formula? Obviously not. Obviously not, because this is common sense. It's like asking you, there were four things then, now there is only one thing. What's the difference of the masses? Obviously, even a 4th standard student will know, okay, I have to add the 4 weights, I have to take this weight and I have to subtract them. Obviously, that will give me the mass defect, the mass difference. So glad, Siswa, you won't forget. Excellent. Now you'll be like, sir, isn't this very good? If more gas, more energy is released, it will be better for the nucleus and it will be very happy. We'll come to that point in a bit. So remember this relationship, E is mc square. You might have seen some t-shirts, you might have seen some memes, you might have seen this relationship many times. Energy can be converted into mass, mass can be converted into energy. Very, very important. Very, very important. Yes. So, Rupesh, concentrate on the class, don't worry. Okay? Students who will be watching IPL, no? So, one advice to all the students who are watching IPL. The batsmen, the teams are scoring runs. You are not scoring runs. Students who are attending classes probably are missing the runs, but you will score the runs in the exam. Remember that line. All right. Now, this comes from, yes, the theory of relativity. This, if energy is, oops, 1 second. Where did it go? If energy is created, then the mass is destroyed, and if energy is destroyed, then the mass is created. Keep this in mind. Okay, so this is how it works. Fair enough. C is the speed of light. Everybody knows the speed of light? Yes. So that is basically 3 into 10 to the power 8 meters per second. I am so happy some of you have pre-board exams and still attending the classes. That shows your dedication, and I'm pretty sure this is going to help you. Now this, forget this upper relationship. The one which is there below is going to help you a lot. The energy which is released, the energy which is associated by combining the protons and neutrons is mass defect into 931. When you convert this into electron volt, and this mass is in atomic mass unit. So usually you do not use SI units because the SI units will look very small for these numbers. So you convert it into AMU and mega electron volt. You will notice that if you take 1 AMU and 1 atomic mass unit and you destroy it, you will get 931 mega electron volt of energy. If you have forgotten, 1 electron volt of energy is 10 to the power, or I can put 1.6 actually. So it is basically 1.6 into 10 to the power minus 19 joules. So this is the conversion factor, but you should remember this formula because most of the times everything will be in atomic mass unit. Very good, my warriors. I hope you are noting it down, and guys, you're going to get the entire PDF as well. Don't worry. Now, what matters is not the not the energy which is released, but the stability, the happiness of those particles is dependent on how much energy is released per particle. Yes. So it matters. What matters is not the total energy released, the energy released per particle. Because, yes, it will be sufficient, Jayant. So, white devil, the conversion comes by converting this, mass, which is in kgs, into AMU. Remember, I had given you this conversion factor right over here. Where did it go? Yeah, this one. 1 AMU is this. So, 1 kg will be how much? You do that. Take this number over there. And 1 electron volt is nothing but 1.6 into 10 to the power minus 19. So, do that. So, you will convert joules into electron volt. That's it. Yeah. So, coming back to binding energy per nucleon. It's the amount of energy which is released per nucleon. It's like, see, I'll tell you, you are a class maybe of 10 or maybe 100 students. You are a class of 100 students. I give you 1000 rupees. I give you how much rupees? 1000 rupees. You are basically, where did it go? Yes. So, you are 100 students and I give you 1000 rupees. We go to another class. There are only 1000 students. Oh my God, too many students. And there I give, or maybe I can put a different example. Just 1 second, right over here. Just 1 second. Yeah, maybe another class of let's say 10 students only. And here I give maybe, let's say for example, see, there were 10 rupees that you are getting per student in the first section or in the first set. In the next section, what if I give, just 50 rupees or maybe let's say 250 rupees, let's say for example. Now, although I have contributed less in the second section, you will notice the amount received per student is more. The amount received per student is more. In this case, it was just 10 rupees per person. Here it is 25 rupees per person. Although my contribution is less. So what matters is how much money is being given to per student or per person. The same way over here also, the happiness of that nucleus, the stability of that nucleus is decided by how much energy is released per nucleon. Every nucleon should be happy. Hence we talk about this factor. So you divide the energy by the atomic mass number, which takes into account the total protons and neutrons. That is why it is like that. I hope this is clear. Is that understood, my warriors? Yes. Now we'll see binding energy exactly, which is coming right now. This energy which is released is called as the binding energy. Why is this energy which is released called as the binding energy? Many students ask. So going back over here, if you have a nucleus and you supply that energy, if you have the nucleus and you supply that energy, you split those particles independently and you will get 2 protons, 2 neutrons, or basically all the protons separate and all the neutrons separate. So whatever energy is released, if you give it back to the nucleus, you will get back the original mass and the 4 particles. So the energy given to nucleus to separate all those particles is called as that binding energy. I hope this is understood. I hope this is understood, my warriors. Is that clear? Okay? Yep. Yes, binding energy is the total binding energy per atomic mass number. Yes, the formula has divided by A, like you can see, it has divided by A, Hari. Yes, it is. Now, the interesting graph is right now over here in front of you. Scientists have plotted and calculated the binding energy for all the elements which are known to you, and a very interesting graph turns up. Here on the y-axis you have binding energy per nucleon, that means how much happiness is there per nuclear particle, and on the x-axis you have the mass number. You have the mass number. If you plot this graph for all the elements, you notice the graph starts from a very low value, meaning for hydrogen, helium like atoms and elements, you will get hardly any energy out of them per nucleon as compared to some other atom like carbon. Like for carbon, when the particles merge, a lot of energy comes out per nucleon. So these elements will be more stable because the nuclear particles will be happier in a carbon atom than in a hydrogen atom. Think about it. Here you will get 25 rupees per person. Here you will get 10 rupees per person. That is what is happening. So why is this binding energy graph important? I am coming to that. If you go on the higher side for iron and molybdenum and uranium and all that, it peaks out somewhere close to iron and then it drops a little bit but does not drop so much also. Okay, now what this graph tells you is that the peak is happening somewhere here. At that particular peak, you will see maximum energy is released per nuclear particle. That means if I were to be a proton or if I were to be a neutron, I would be happy to be here rather than being here or even here, because more energy is released. Remember, when you release, you become happier and you become more stable. So these elements, protons and neutrons, are much stable than the protons and neutrons of these elements right over here. I hope this is clear. Now, why does the drop take place? The drop occurs because after a point, the nuclear forces are not able to bind with so many protons. Imagine this, hundreds of particles, so many particles. Just imagine 2-3 cricket balls will be in your hand. So, you know, the balls can interact with each other. But imagine 100 cricket balls. The cricket ball here and one cricket ball here can hardly see each other. They can hardly interact with each other. There is only a limited sphere of influence around each particle to which they can interact with. Beyond a certain point, it becomes a trouble to hold so many neutrons. In fact, the spins work against their favor. Remember, nuclear forces depend on the spins. Now, when there are so many neutrons which are holding on to each other, it's like there is a full playground full of students, maybe, I don't know, brothers, sisters, who don't like each other or who always fight with each other, and there are their moms who are holding on to them. There's one mom holding on to, hey, listen, you two study. Another mom, hey, listen, you two study. And there is another mom, okay, listen, you do this work. Imagine so many moms, so many, kids out there. These moms are also going to fight. Hey, you shut up. Let me concentrate. Hey, wait a minute. Why is your kid shouting? So there is going to be one chaos out there. So these neutrons too will have a chaotic behavior after a point. So they will not like to be in that nucleus. Hence, that is the drop. I hope you have understood this. Yes, Bobby, I will reply, bacha. Don't worry, I will. And that is why the elements here would try to become these elements. The elements here will try to become these elements. But it is a difficult process. When it goes from here to here, atomic mass number decreases, it decays. Yes, Simply Wolf, it will be useful, obviously, same topic. Guys, the theory will not change. Nucleus will remain nucleus for all the chapters, all the exams, remember that. Okay, so it will decay. So this is called as fission. Fission, you cut it. Okay, so you cut the nucleus, you break it apart, you make it into a smaller nucleus to make it more stable. That's called as fission. Is that understood? Everybody clear about these concepts? Shall we start with some questions? All right. And before we begin, remember the entire PDF of today's class with my handwritten notes will be available to you in the Telegram channel. If you are still not joined the Telegram channel, make sure you join that ASAP. Here comes the first question. C14 and N14 are the pairs of isobars, isotopes, isotones, isodiphers. Let's see how many of you can get this question. All right. Hi, Sirupa. Welcome. Yes, Sucharadya, that's why fusion fission occurs. I hope this is clear in everybody's mind, and let's see how many of you can answer this question. What is the answer? Is it isotones or is it isobars? Well, the correct answer is indeed isobars. Perfecto. Why? Isobar. Remember, in a bar, who goes? Two friends. So in this bar, which are the two friends? Proton and neutron. So isobar, proton and neutron together. So the total number of protons and neutrons, that is called as the atomic mass number, 1414. Hence, atomic mass number should be same, isobar. Remember, bar. In bar, two friends. Who are the friends? Protons and neutrons. Okay, next question. What is the ratio of the radii of this element and this element? Let's see how many of you can do this. It's an interesting question, and let's see how many of you can quickly figure out the answer to this question, maybe within 30 seconds, not more than that. Come on, my warriors, figure this out. Okay, let me get my pen up and running. Yes, the ratio of the radius, I just told you, the radius is directly proportional to a raised to 1 by 3. Hence, the ratio of AU upon the ratio of the radius with the, AG will be the cube root of the atomic mass number of AU. That's 197. And of this is 107. One thing I'm sure that this number is definitely less than 2. Definitely less than 2. Everybody agrees with this? Hence, the cube root of 2 will be definitely less than 2 also, right? It has to be definitely less than 2. So, this number, the ratio should be definitely less than 2. Which number is less than 2 over here? Only this one. Just mark it. That's it. Done, done, done. You don't even have to sit and calculate. That's what toppers do. Okay? Average student or below average student will be like, oh my god, I need to find cube root of 197 by 107. Average student will first divide them. He will get some decimal values. Then he will invent a method in the exam hall to find the cube root of these decimal numbers. And by the time he invents that new method, the exam paper will be over. Hello Anthony, nice to see you back. Okay, moving on to the next question. On your screen now, binding energy per nucleon is maximum for intermediate nuclei. Yes, it will. White Devil, for CBSE boards, you don't have objective. Theory can come in different way as short answer or in a different way. You should know the theory. Maybe they can ask you to write a paragraph or give examples of isotones and isotopes. I don't know. They can ask things like that, right? So board theory, will not help you much in JEE and NEET preparation, but JEE and NEET theory will help you in board preparation. You just need to go through your NCRTs for boards. That I'm pretty sure you can do. Bharat saying B, Kanwani saying A. Come on, my warriors. What is the answer? The answer is intermediate nuclei, not lighter or heavier or none of the above. I just told you about this just some time back. Moving off back to this chart. The binding energy per nucleon is highest, not for low weight or heavy weight, somewhere in the middle. Somewhere in the middle. So that's why the answer for this question is intermediate nuclei. Yep, very good. Mahadev, same previous question asked yesterday, I calculated. Very good. Mahadev, very good. Okay, don't do that. Not needed. All right, moving on to the next question. Mass defect of the nucleus of helium is 0.0303 AMU. The binding energy per nucleon in mega electron volt is roughly. Hi Sonalika, welcome back. So question is binding energy per nucleon. So binding energy per nucleon is asked. Binding energy is delta M into 931 mega electron volt and atomic mass number. So what is delta M over here? The mass defect is clearly mentioned to be 0.0303. So 0.0303 into 931 mega electron volt. Number of nucleons present. Helium. How many nucleons present, guys? Okay. No problem for now. I will not mind. Okay. So what is the number of nucleons? Obviously 4, right? Let's do some magical things over here. Just shift 2 decimals and shift 2 decimals here. Shift this decimal here. And I know this is 0.0. So shift the decimal over here. See what will happen. It will look like this, 3.03 into 9.31 divided by 4 mega electron volt. 9 3s are 27. Everybody agrees? This is 27. But now think about it. 9 into 3 is 27. This is 9.3 into 3.03. Slightly more than that. So something more than 27. Maybe 28, 29, somewhere around that. So what will be 28 by 4? It is 7, right? So somewhere close to 7. No, the answer will be somewhere close to 7. Understood how to do the approximation? This is the kind of manipulation you need to do. Very good, Rupa. Very good, Siswa. Daljan. Excelente, Harisma. Hiroshima, I will call you. Okay, sorry. Going on to the next question coming up on your screen. Very similar, but here calculations are involved. Main thing is you should be able to write down the calculative part or the initial equation properly. Rest calculations is just time consuming, but you can do. Let me see how to do this, show you how to do this particular question. The binding energy of alpha particle has to be found. Mass of proton, mass of neutron and alpha particle is given. So first thing that you will do is delta M. So remember initial mass is always more. And so initial mass minus the final mass is the mass defect. Initial mass, alpha particle has 2 protons, 2 neutrons. So 2 times mass of the proton, which is 1.0073, okay, plus 2 times mass of the neutron, which is 1.0087. This whole thing minus final mass is already given, which is 4.0015. Whatever answer you get, it will be in AMU. Okay? Whatever mass you get, it will be in AMU. Now the question is find the binding energy. So the binding energy formula is del M into 931 mega electron volt. Whatever answer you get, put it over here, you shall get the binding energy value. That's all. So I have done the calculation for all of you. Okay? So the same thing, 2 into 1.0073 plus 2 into 1.0087 minus 4.0015. It comes out to be 0.0305 AMU. Multiply it with 931. You shall get the answer as 28.4 mega electron volt, which is option B, I suppose. I think this is something which you can do. Everybody understood? This is how you calculate, my warriors. No divided by A. Read the question. Only binding energy is asked, not per nucleon. Many students make that mistake. So see what is asked. Is it binding energy or per nucleon? Many students forget to divide it by A when per nucleon is asked, and some students end up dividing by A when it is not asked. So please read the question. Okay, that's very important. I'm so glad, Buana. I'm pretty sure that 0.1K subscribers will be done soon, probably by tonight, I don't know, or maybe by tomorrow. Yes, party time. Hello, Amit. Welcome aboard. Okay, so let's move to the next part, and that is radioactivity. Radioactivity. And we are going to talk about those radioactive reactions, and also we are going to talk about the different kinds of fission processes that can occur. So basically, whenever you have heavy elements like the ones over here, heavy elements like the ones over here, these nuclear particles are not happy in this house. They are not happy. They don't get so much happiness. When you see this graph going up, you should be happy. It's like kids asked to stay in some class, they are very happy. Some kids, the same kids, you put it in other class, they are not happy. The same kids, you put them in some other class, they are not at all happy. Sections or class, whatever you want to see. So the students in this class will always try to come over here because this section is good. You get a lot of happiness, a lot of energy per nucleon. You get a lot of money. Okay. So these particles, when they try to come over here, they split, they decay, and they emit particles. So the kind of particles that come out of them are the radioactive particles which are emitted. So this is your radioactive material. It glows because it emits a lot of light, energy, heat, everything comes out of it. And these particles that come out usually are alpha, beta, and gamma. What are the particles? Alpha, beta, and gamma. What is alpha? Alpha is nothing but your doubly ionized helium. Okay, so what will be the charge on alpha? It will be +2. What will the charge on alpha be? It will be +2. Beta is nothing but your electron. So strictly speaking, their charge is +2e over here. Here the charge will be -e because it's an electron, and gamma is a photon, so no charge on it. There is no charge. It's a photon, like X-ray or whatever, your red color light or infrared or anything, long radio waves. That's how it is. Hi Jyotsna, welcome aboard. I hope you are enjoying your time out here. And if you talk in terms of atomic mass numbers, well, this has 4 AMU roughly because 4 particles, 2 protons, 2 neutrons. So it's very heavy, bulky, big things, big chunks. Beta, well, that's electrons, so negligible, very close to 0. For gamma, mass is not defined. You never talk about mass for photons. It's illegal. It's illegal to talk about mass. Okay? For whom? Electromagnetic rays and radiations. Gamma is an electromagnetic wave. Okay? These are your particles. This is your gamma photon or electromagnetic radiation, which has electric and magnetic fields. Keep this in mind. Okay. So if you notice, alpha particles, they are bulky. They are like big fat people. 2 protons, 2 neutrons. If they try to go through some obstacles, they will get stuck. It's like one big fat person trying to enter into a narrow gap or a narrow door, he will obviously get stuck. But beta, they are relatively tinier, so they can pass through some sheets, but still they are quite bulky as compared to gamma. Gamma is like photon. Photon is like a point. I mean, like you cannot even see a photon, guys. It's crazy to even imagine the shape of a photon. So they can pass very easily through many sheets of, obstructions. So whatever you take, paper, aluminium, okay, so they will pass through it. Keep this in mind. I hope this is clear. So alpha, 4 atomic mass, 2 protons. Beta, no atomic mass number, but -1 charge. Gamma, no atomic mass, no atomic charge, obviously. So 0, 0. So whenever you see an alpha decay, then you will notice that the atomic mass number reduces by 4. Atomic mass number, you can say, reduces by 4, and atomic number, because 2 protons go away in that alpha particle, the atomic number reduces by 2. White devil, maybe not now, soon. Next, beta particle. Because there is -1 here, always try to conserve. Always try to conserve the one on the prefix and on the suffix side. If you look at the, not prefix, subscript and upscript over here, the one on the top and the one below. So these numbers should be conserved. A will be A minus 4 plus 4. Z will be Z minus 2 plus 2. Here A will be A plus 0. Z will be Z plus 1 minus 1. Because beta has negative 1, so you have to add plus 1 to compensate and balance the reaction. In case of gamma, there is no change in atomic mass number or atomic number because there is 0, 0 over here. Keep this in mind. Balance it just like you balance your chemical reactions. So just balance it. You will be able to see it. Everybody understood? Hi, Jinkyo. Everybody understood how to balance these equations? I put it up right in front of you. Okay, so let's move to some questions. But before that, remember, what is the difference between fission and fusion? See, when you talk about fuse, fuse means come together. You fuse two things. You fuse means you melt and you blend them together. They become one thing together. That is fusion. Fusion occurs in the sun. Okay, so these particles come together and you will see a lot of energy is released. Fusion can happen with many kinds of elements, many kinds of atoms that you can think of, not just with helium or hydrogen. So you will see that when two particles are asked to come together, it requires a lot of energy which has to be given to them, because it's not so easy for two particles or two nuclei to come together and interact and then form one single nucleus. That's fusion. Similarly, you have fission. So when a heavy particle breaks down into smaller particles, either artificially or naturally, that will be your fission. Okay, so here what has happened, there is a heavy nucleus. It's like your lot of things are kept together like carom. This is like a carom board, and you take the striker and hit it, or the striker goes and hits and it spreads it apart. It breaks it down into smaller daughter nuclei. This is called as the parent. This is your smaller fragments which are called as the daughter. Is that clear? What happens in gamma decay if there is no mass and charge is changed? White devil, it's got to do with the nuclear energy states. So basically it's got to do with the excitation energies of the nuclear particles. So nucleus also has suborbitals and orbitals and different energy levels. Just like in an atom, when an atom gets excited and then comes back to the ground state, photon is emitted. Same way a nucleus can be excited. That star mark stands for the excitation. And then when it becomes relaxed, meaning it comes back to the ground state, it releases that energy. So it's based on the excitation within the nucleus and coming back to the ground state. So that's why you do not see no proton or neutron was involved in this. All right. Okay. So the last important thing right over here is the Q value. Q value is basically the energy which is associated with the fission or fusion, depending on whatever is the mass before and after. So let's say there were some particles before, there are some particles afterwards. Then Q value is the energy which is involved, and that energy has to be calculated by mass defect, delta m c square. That mass defect is the initial mass and the final masses subtraction. I hope this is clear. Okay. How, when electron is released, Z gets increased by 1? John Benito, I'll tell you, hold on. But first, I hope this is understood. It's the initial mass minus final mass gives you the mass defect into C square gives you the energy. This is called as the Q value of the fission or your fusion. Now going back to this over here, alright. So in a beta decay, what exactly happens is a neutron converts into proton plus electron. So this element has a neutron, neutral particle. If it splits into one proton, what will happen? One extra proton in the nucleus. That's why Z will become +1. Understood? And that electron is ejected out. So that electron comes out. I hope that answers your question. Is that okay, Joan Benito? I'm so glad, Satya Velupalli. That is exactly what I want. Okay, so I think I'll just erase this right over here. Okay, cool. Great, John. That's all I want, guys. Please keep asking doubts and help each other also. It's not like only I should answer, okay? You guys are also, smart. You should also help each other because we are all fellow enthusiasts. Enlites. Okay, starting with some questions coming up on your screen. A and B are isotopes. B and C are isobars. all three are radioactive. Which of the following is true? Very, very nice logical question, conceptual question. If you can get this, I would be very happy. Let's see how many of you can get this. A and B are isotopes, B and C are isobars, all three are radioactive. Which of the following is true? Figure this out. Come on, my warriors, figure this out. A and B are isotopes. Okay, let's try to do this. A and B are isotopes. That means their Z should be same, but A could be different. Let's say A1 and A2. B and C are isobars. That means their atomic mass number will be same, and here the atomic number will be different. Z1 and Z2. Is that clear? Now, which of the following is true? A, B, C must be the same element, or can they be the same element? Obviously, all three together are not the same element because Z1, Z1, Z2. So definitely A and B are wrong. A and B are eliminated. Out of C and D, A will convert to B or B will convert to C. Okay, here atomic number is changing, atomic mass number is changing. Here atomic number is changing. Interesting. Which one do you think is possible out of these two? Here atomic number is not changing, atomic mass number is changing. If you go back to this slide, you will realize in these three reactions, either both remain the same, or atomic number changes, or both change. I'll repeat, nothing changes, or atomic number changes, or both change. Now if you go back to this slide, here atomic number is not changing, but atomic mass number is changing. So obviously you cannot go from here to here. This is not possible because atomic mass number is changing, atomic number is not changing. If it does not change, this is not possible. Here atomic number changes and this doesn't change. This can happen in case of a beta decay. Have you noticed this? In case of a beta decay, atomic mass number remains the same, Z changes. So definitely this is possible. So possible that B will change into C through radioactive decay. Yes, so option D is correct. Very good, excellent day. It takes some time, but very interesting question, isn't it? A lot of students get confused how to do this, but I have taught you the proper approach of solving the problem. Moving on to the next question. When a neutron decays spontaneously, what will it decay into? Proton, electron, antineutrino, proton, electron, neutrino, proton and electron, and neutrino and antineutrino. My God, crazy things. Wow, let's see how many of you can get this. Yep, it is a correcto. Let's see the next amazing go question coming up on your screen. And what do you think a neutron will decay into? Obviously, one thing I know, a neutron decays into proton and electron. But what is the other particle which comes out? What is that other particle which comes out? How many of you know this? Some are saying A and C. Definitely C is not the answer. There is something more that comes out. Yep, and what is that something more? It is antineutrino. Keep this in mind. It is antineutrino. The symbol for that is nu and put a bar. This is antineutrino. Very, very interesting result. This particle, it's not like it has mass, it does not have charge. It's a very new kind of particle which you will not study in JEE or NEET. Okay, but when you take up higher branches of science and do pure science and research, you will study more about it. Okay, but for now, remember it's also a kind of a particle, neutrino and antineutrino. These are subnuclear particles which are created during nuclear reactions. Okay, just like when you studied atom when you were in 6th grade. Imagine when you were in 6th or 7th standard, atoms, oh my God, nice. Then somebody told you, you know what, atom has two parts, nucleus and electrons. You're like, oh my god, wow. Then you're like, okay, you know what, nucleus, that also has two parts, protons and neutrons. Oh my god, crazy. And then slowly you get to know, oh my god, wait a minute, even protons are made of small, small things, neutrons are made of small, small things. There are even tinier particles below that. So those are those small, tiny bits of particles whose, trailer you are seeing right now over here. Is that okay, White Devil? Cool. And you can also move this around and make some nice reactions. Let me tell you that. Take the electron here. So neutron plus, minus electron. My bad. Neutron minus electron. And bring that over here. Minus neutrino is going to give you proton. And negative of an electron, well, I can just write it like this. As electron has a negative charge, negative of negative is positive. So I can write it as a positron. This is your positron. The twin brother who was lost in one mela, in a fair. There was a fair and this was the lost brother of electron. Identical properties but a positive charge. Imagine an electron with a positive charge, that's called as a positron. And the negative of anti, minus and minus becomes plus, that becomes your neutrino, and this becomes your proton. So this is also a reaction. Isn't it crazy? Isn't it amazing how you can go from this reaction to this reaction? It's like your maths, yeah, little bit like your maths. So proton can give you a neutron and a positron and a neutrino. Isn't it crazy? Did you love this? Okay. So you'll be like, sir, what is neutrino? Neutrino is the antimatter for, or the opposite particle or the twin brother for antineutrino. Like electron has positron, similarly antineutrino has neutrino. Think of it that way. Everybody fine till this point? Don't have to break your head, sir, my god, I didn't understand, over the head, sir, tangent. This was tangent to me. Was it a tangent, guys? Let me know. If it was, don't worry, you are not alone. This is not there in detail. You just need to know a neutron decays into proton, electron and antineutrino. Moving on to the next question coming up on your screen. Fusion takes place at high temperature because, come on, answer this question, my warriors. Okay. Fusion reaction takes place at high temperatures because. Why does it take place at high temperature? What is the reason for that? Is it the atoms are ionized at high temperatures, or molecules break up at high temperatures, or nuclei break up at high temperatures, or is it because kinetic energy is high enough to overcome the Coulomb repulsion between the nuclei? Come on, my warriors, figure this out. Somebody is saying D, Jarin saying D, White Devil, Daljan, Joan, Niranjan, Sonalika, Siswa, everybody is saying D. Are you guys correct? Or are you guys correct? Are you guys correct or are you guys correct? Yes, you guys are correct, obviously. Joking. Come on. To bring them together, you need to push them hard. You need to overcome their electric repulsive forces to bring them together and fuse and form a single nuclei. Hence option D, a kinetic energy enough to overcome their repulsion is involved. Okay, come on. Street boy, nopes, bacha. Now, come on, let's see how many of you can spam the answer for this one. Alpha, beta, gamma radiation pass through a gas. Their ionizing powers. So when the particles hit air molecules like nitrogen and oxygen, what will happen? The nitrogen, oxygen molecules, you will see their electrons get knocked out and the gases become ionized because their particles are transferring their energy to the air molecules. So, how much is the ionizing power, or whose is more, whose is less? Is it more for alpha, beta or gamma? Come on. Some of you are saying B, some of you are saying A, some of you are saying C, I guess. Okay. Okay, a lot of you are saying B. Okay, why are you saying B? You guys are thinking gamma. So gamma is highest, then comes beta, then comes alpha. Okay, guys, you are a little bit wrong over here. The answer is alpha, beta, gamma. Alpha is higher. Okay, so then comes beta and then comes gamma. Then you're like, no sir, C is wrong. I think B should be correct because gamma particles, photons, they travel at very high speeds. They're very teeny mini, mass not defined. So most of the gamma particles will pass through the nuclei, through the atoms. Remember Rutherford's experiment? Do you remember? Most of the rays just pass because will not strike the nucleus or electrons. So gamma particles, most of them will pass, very few will end up striking the electron and ejecting it out. Electrons, which is beta, slightly heavier, slightly decent size. So when they hit, they will transfer some momentum, they will knock out those electrons. Fine. Alpha, big fat. Imagine an elephant running at 60 kilometers per hour, guys. Imagine an elephant running at 60 kilometers per hour. It will be crazy madness, right? So something like that for alpha. It will definitely knock out those electrons. Beta is like a cockroach, or maybe, I don't know, a bird maybe, a small bird, a sparrow or a crow. Yeah, a crow or a sparrow flying at, I don't know, maybe 1000 kilometers per hour. Yeah, it's faster, but it's small. Like, sir, but it's very fast, sir. Maybe it's got a very good effect. But again, think alpha is like an elephant which is running fast. So it's got crazy ionizing power. Yep. So that's what it is. Cool. Okay, happens. Chandralekha says, okay. So be little careful with the question and what is asked. A material radioactive decays from A to A1, A1 to A2, A2 to A4. A3 is not there, directly A4. If A has 52 atomic number and mass number 110, what is the mass number and atomic number for this element? Come on, this is straightforward. You should be able to do this. Very simple reaction, my warriors. Come on, quickly figure this out. A has 110 atomic mass number, atomic number is 52. So the moment you get alpha decay as the first decay, mass number reduces by 4, so this will become 106. This will give you A1, and 52 will reduce by 2, so this will become 2. Then you have beta decay. In beta decay, mass number does not change, so it remains 106. You have A2 number. Sorry, what did I just say? 52 will become. I should have written 50 over here. My bad. So sorry, guys. This should have been 50. Okay, so this is 50. Now the 50 should become 51 because it's beta decay. So this will become 51. Cool. And the last thing over here, A4. That's why alpha decay. Atomic mass number reduces by 4. So it will become 102. And this one will reduce by 2. So 51 minus 2. So that will be nothing but 49. 49. That should be the answer. Let's see how many of you have got this. 102 and 49. Perfecto. Option D. Correcto. Very goodo. Amazing. 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 Yes, 49 will come. Yes, 49 will come. Definitely, Siswa. Yeah. So that's the correct answer. So you should know what each reaction does to the atomic number and atomic mass number. That's it. It's very simple. All right. Moving on to the next question. Yes, I think we are coming to the last part of this chapter, which is radioactive decay. So when you have a heavy element and it starts decaying naturally, on its own it is unstable, right? You don't need somebody's help. Naturally only it will start decaying into smaller daughter particles. It will emit alpha, beta and gamma. Then those particles are radioactive materials, uraniums, isotopes, thorium. So many elements are there which are unstable naturally. Even our body has that. Our body also has a radioactive material. How many of you know this? And what is that radioactive element, or what is that radioactive material inside our body? Even you are producing radioactive, radiations. What is that? Anybody knows? Come on, Enlites. You should be knowing this. Come on, my warriors. What is that radioactive element called? Okay, come on. Anybody knows? Meanwhile, I'll start teaching. Let's see if you remember these laws. The first important law that you should know is the radioactive decay law, the disintegration law, standard, very important. The rate at which elements decay is proportional to the amount of radioactive material present. So this is your radioactive decay law. dN by dt, let me just get it over here. Yeah, this dN by dt is nothing but called as the activity. This is called as the activity, and you can see the rate of decay, the number of nuclei undergoing decay per unit time is proportional to the total number of radioactive nuclei. The total number of radioactive nuclei present here. Lambda, which is there, this lambda is called as the decay constant, the disintegration constant. It depends from each element to the other. Every element has different lambda. Uranium will have different, plutonium will have different. So every element has a different lambda. It will be given to you. Yes, some of you guys are correct. Yes, correcto, Daljan and Harishma. It's carbon. And basically every human body or most of the living organisms have this C14 radioactive isotope, which is present in a specific amount. It's present in a specific amount. So you'll be like, sir, if that radioactive element is present in our body, it will decay. No. After 2-3 years of my, when I'm born, it will go off. Then I'll be fine. I will not be radioactive anymore. No. Your body keeps on absorbing, producing it, and the particular level of C14 is maintained within your body. A particular percentage of C14 is always present in every living organism through all the processes that happen within your body. But now what happens is, when somebody dies or something is dead, then the production level stops. The production level stops. Because of which what will happen is, you will see the percentage of this isotope will slowly start coming down. If you know how much percentage should be there in a living organism, and if you know how much material or how much percentage is there right now in the current organism which is dead, comparing the two, you can find out how much time has gone by from the time of death. Did you understand, my warriors? How many of you got this? So in a living organism how much should be there, in the dead organism you know how much is there right now. Comparing the two, you can find out how much time has passed from its death. That's how it's done. Miss Bastard, this is an English channel, so we'll be talking in English. We also have English channels and Hindi channels. That's where we'll be talking in Hindi. So V Madesh, I had recently conducted a poll for term 2 syllabus, whether you want, but I think majority of you said that you don't want, you just want JEE and NEET studies. All right, so I think we'll be going ahead with that, at least for the time being. Great. So talking about the next few formulas, the activity or dN by dt is lambda n, like I just told you, and the formula for activity is A naught e to the power minus lambda t. Also the same formula works for number of nuclei present at any time. It's n naught e to the power minus lambda t. N naught is the initial amount of the material. N is the current amount of the radioactive material left, which is left right now. So e to the power minus lambda t comes via integration. The unit of decay, the activity, is becquerel or Curie, but you generally use becquerel, which is 1 disintegration per second. Okay, is that clear? All right. Okay, is the audio low? No, I don't think so. Audio is low, it should be fine. Okay, now there is a very important, why the negative sign, Siswa? Because decay means reduction. So that's why the negative symbol signifies that it is reducing. I hope that is clear. So it is not increasing. dN by dt, okay, with the negative sign resembles or tells you that it is decreasing. I hope this is fine. Cool? All right. Now, if you plot the graph of n with the time, the number of nuclei left with time, obviously it will keep on going down, and eventually it will settle down. It will reach an asymptotic number. So it starts here with n naught initial at time 0. Slowly it starts reducing like that. It's called as an exponential decay. This is exponent and this is decreasing. That's why exponential decay. So the graph is an exponential decay curve, and this is very similar to your capacitor decaying circuit. How many of you remember your capacitor discharging? How many of you remember capacitor discharging? Sudarshan, Sudan Vignesh, the 12th standard, we'll be conducting a more targeted studies on the channel, because I already have recorded and kept all the detailed classes for 12th standard students. It's there in the playlist. Entire chapters are there. So no point repeating the same for 2023. In fact, we'll be doing more targeted studies. So I would request you to watch those lectures. In addition to that, I'll be doing some targeted, approaches for every chapter. Okay, this is important concept. That is what you should do. This is how you should solve the problems. All right, clear? All right. Now, the time it takes to become half the original value is called as the half-life. So, the half-life of any element is log 2 by lambda. You would have studied this in first order kinetic reactions in chemistry. Haven't you guys? Yep. Okay, great. Okay, so V Madhve sure shot will not come now. It will come later on. It will come later on. Okay, first I want to do the entire term 2 0 to superhero series. Today I am doing nuclear. Just few days back I was doing atomic structure and photoelectric effect. Before that I have done waves, right? I have done all these chapters. Tomorrow there is electromagnetic waves. After that semiconductors is going to come. After that ray optics is going to come. I'll finish the entire term 2 syllabus in this 0 to superhero series. After that, what will I do? After that, I'll be doing your targeted, studies for term 2 board exams. And also simultaneously, we will work on your JEE and NEET syllabus. Yes, semiconductor is coming. It's already there in upcoming MS Biscuit this. If you see upcoming lectures, upcoming videos, you will see it right over there. Average life is also important. How much average time does any nuclei survive? If a nucleus is taken, how much time does it survive? So that is called as the average life of the nucleus. It is 1 by lambda. Remember, half-life has log 2 by lambda, and average life has 1 by lambda. That's the only difference in the formula. Keep this in mind. Okay, let's start with some questions coming up on your screen. Is it easy to get 50 marks in physics? Sham, you're talking about JEE or are you talking about NEET or some other exam? Please let me know. Hi Ajay P. Half-life of PA218 is 3 minutes. A mass of 16 gram will remain. How much will remain after 15 minutes? Let's talk about this question and try to solve this. Come on, guys. Oh, for JEE, Sham, 50 marks in physics is very easy in JEE. Yes, it is actually very easy. Getting above 80 is the tough part. And obviously getting more marks is even more difficult. But 50 is very easy, straightforward. I mean, like, it's not at all hard. And that can easily fetch you close to 98, 97 percentiles. Yep. Now, for this question, remember that time is 15 minutes, half-life is 3 minutes. So, number of half-lives. Every 3 minutes, it becomes half. 3 more minutes, half. So, 15 minutes, if you divide it into 3, you are going to get 5. 5 half-lives are over. So, if 16 grams was there, after 1 half-life, 16 by 2 will remain. After 2 half-lives, half of that. After 3 half-lives, half of that. After 4, half of that. After 5, half of that previous. So basically, it is 16 by 2 raised to 5, which is 16 by 32, which is 0.5 grams. That's the answer. 0.5 grams. Yes, option D. Is that clear? Without it will start in May, June only. Yes, the 2024 batches after your board exams. Yes, Tirthi Ajesh, if you start NEET preparation now, you can still get a seat. Bacha, there's time. You have to work hard. Make use of the crash course. Obviously, that will help you reduce your burden. You can concentrate and do targeted and strategic studies rather than wasting your time. Use the mock test and assignments. Watch my lectures on this channel. Obviously, all these things together, I guarantee that you will get something, bacha. Okay, let's move on to the next question. A radioactive material decreases by simultaneous emission of 2 particles with half-lives this and this, the time after which 1/4 of the material will remain. Okay, so let's see how many of you can get this. Harshavardhan, yes, will slowly, I'm pretty sure probably by tonight or tomorrow we'll be reaching that 100K, and lots of I don't know how to control my excitement, but I don't know, I'm not at all very I would say over the board. I'm happy, but it's all taken time. So I know what amount of hard work I have put in, what the team has done, what the people who have worked behind the scenes have done. So it takes a lot of effort, and if I become very happy, then I will not work more. So I want to probably keep very high targets for myself so that I do more for all of you. And 100K is not the final destination. Our destination is much more beyond that. So every student in this country should benefit from this English medium channel, which is there for JEE and NEET aspirant students. All right, so let's try and solve this question. First of all, when you have a radioactive material which decays via two ways, each one having separate lambdas, then the effective lambda, the effective decay constant is lambda 1 plus lambda 2. This is something which you should know. All right. Okay, great. Now, lambda is nothing but log 2 by t half. I just told you t half is log 2 by lambda. So lambda is log 2 by t half. Everybody knows this. So lambda 1 will also be log 2 by t half of the first element and log 2 upon t half of the next element. This half-life is the effective half-life. So this is your effective half-life. Log 2 cancels. So T effective will be T1 T2 upon T1 plus T2. Let's start substituting everything that we know. Half-lives are given 810 and 1620. So 1620 into 810 divided by 1620 plus 810. Okay, let's see what do we get next. So 162 and 81. 81 into 2 is 162. So this will be 2 into 81 into one more 81. Two zeros are there, so I'll bring it like this, 10 to the power 2. 1620 and 810. You can check that out. It will be nothing but 243 and into 0. So 243. So you can also write this as, check this out, because 1620 is 810 into 2. 810 into 2 plus 810, that is 3 times 810. So 3 into 81 and 1 power of 10. Okay, a lot of things are going to get cancelled out. 81 goes, 1 of the 10 goes. So it will be 2 into 81 into 10 divided by 3, of course. All right. Now, once you have got this, you can see this will be 162 divided by 3. So this will be nothing but 5, and this will be nothing but 4 and 0. Yes, this will be 540. So this is the effective half-life. This is the effective half-life. The question is time after which it becomes 1/4. 1/4. So if initially n was there, after one half-life, it will become n by 2. After one more half-life, it will become n by 4. So the time taken will be 2 times of the effective half-life. So 2 into this number, which is 540, which is going to be 1080. That's the answer. Option A. Just check this out. Yes, 50 marks. Bhavya, it is more than that. It is not for 50, it is for more than that, of course. Yep, 1080p. Yep. So, Tirthi, Acha, like I told you, bacha, you will have to study very strategically and systematically, narrow down your preparation with crash course, make use of YouTube classes, and make the best use of your time. Study for 12 hours to 15 hours a day, make timetables, and allocate your resources and time properly. Study important chapters, study high weightage chapters only first. Okay, very good. So, we have reached the end of the session, and this is the last question, but this is for homework. Make sure you drop the comment in the comment section after the video ends, and the solution for this will be available to you, in the PDF form in our Telegram channel. If you're not joined it, please join it right away. Yeah. So Vedant, I'm not sure whether my batch will be there or not, but you will definitely have an English batch for 2024. Okay, great. So guys, we have the JEE crash course and we have the NEET crash course for all the students who are currently studying with all or any coaching institute, or who have not undergone any coaching at all, or who are just studying from YouTube. So in the crash course, we have, interactive classes with polls, hotspots, along with a second teacher to solve all your doubts, because it can get disturbing when you ask your doubts and it can become very confusing. So we have a class teacher dedicated only in small groups to answer all your doubts. Also, you get all India rank test series where you can compare your ranks with the toppers and the rankers, so that you get a realistic feel of where you stand in the competition. This is both for JEE as well as NEET. Not just that, you'll also get the recordings. The recordings will be available till the last exam, be it JEE or be it NEET, and you will also get assignments for all the subjects and all the chapters, be it for JEE or for NEET. All of this is at a very affordable price point for 1,800 rupees only. And if you are interested to join this batch where even I am teaching my warriors, yes, even I am teaching, all you need to do is go to the description box right now over here, and you will notice that there are links over here for JEE as well as NEET crash course. Both the crash courses, even if you click the NEET crash course, you can see right over here, you have applied the coupon code SHCC, you have saved 10%. It's only for 1,800. Click buy course, that's it. You use any of the methods mentioned over here. Same thing for the JEE crash course right now. And remember, I'm teaching right over here. Okay, so not just me, all the awesome and the best teachers who have produced ranks. Again, 1,800, click buy course. And if you want more details, you can go ahead and check it out right over here. All the details, how you're going to get the study material, tests, everything have been mentioned. So go ahead, guys. Time is running out. I'm pretty sure you don't want to miss out on this golden opportunity, because the price might go up or down, but the time will never come back. Remember this. Yes, this chapter is done. All right. Yep. Are there any combined courses like JEE and NEET? So if you are preparing for NEET and JEE both, most likely I'm guessing you are more interested in NEET. I would suggest you to join the NEET crash course, because anyways physics and chemistry will be done. And for maths, if you want it separate, so then you'll have to go to the JEE crash course. So guys, you have to choose between one of them. Okay. So my Telegram ID, instead of that, you take my Instagram ID, captain_Shreyas. So probably I will end up replying there. Okay. So I'm not using my Telegram Vedant so much. Okay, for personal interactions right now over there. Yeah, definitely Sonalika. Looks like you guys have fallen in love with Pandu Champa and the beautiful Champa, of course, and Andu too. Okay, so if you are studying in 7th and you want to enter ISRO, can I study for my syllabus? Tiny foods, tiny kids. Oh my God, you are really tiny, bacha. So all I would say is focus on mental ability, focus on visualization, focus on scientific phenomena, focus on experiments, focus on calculation, focus on your speed. That's the skill you need to work on. It's not that you have to study a subject. You don't have to study a subject. You are very young bacha. You have to develop skill set, understanding, analytical skills, visualization skills, calculation skills. These skills will help you understand the subjects very easily when you reach higher grades. Okay? Yes. So guys, remember one thing, that we are going to conduct lot of lectures just before your board exams. I am planning marathons, I am planning one-shots, NCRT series and all of that very soon. But let me complete the zero to hero term 2 syllabus, right? I hope you understand. That's what needs to be done right now. I'm so glad, Sonalika, you enjoyed it. Hi, Fatima. Looks like you have come almost to the end of the class. And I'm so glad, Siswa, you enjoyed the class as well. And my warriors, please understand, sometimes it's possible that I miss out on replying some messages, but I hope you guys understand it very well. All right, Naz, can you leave a comment maybe on some picture? Maybe I will definitely, reply to you. Yes, we are going to give you giveaways on completing 1 lakh, and probably some new videos also coming up. So it takes time, but yes, a lot of videos and some giveaways coming up for your love and support as well. Thank you very much, Bhavya. Take care, Kriti. Take care, Naz. All right. Have a great time. This was your Captain Shreyas signing off. Hasta la vista.